Potential difference is the proper word for what most people call voltage. And you'll hear a lot of people call it voltage, even really proper physicists, engineers, that kind of thing. They'll say voltage all the time because it's easier to say than potential difference. But technically, we're meant to say potential difference. Or if we're being lazy, we can say PD, which you've written here, P.D. Okay? Now, potential difference is one of those things that people get really scared about because they think it's a really confusing idea. And it is if you don't break it down into sections. Now, there's two words in potential difference, potential and difference. The word difference, I'm sure you already know what that means. But the word potential in physics is one of those other words that has another meaning. Okay, so potential in physics is how much energy an electron has at a given point in a circuit. That's all it is. So electrons have more energy at some points and less energy at other points because they're giving it out to components, they're taking it in from the battery. And it's really important to know what that is. So potential is how much energy an electron has at a given point in a circuit. Now if we look at this circuit here, it's got a 6-volt battery in there and a bulb. Now an electron will travel through this battery and be given 6 units of energy. As it travels through the wires, it doesn't really give much of that energy out because wires are actually quite easy for it to travel through. So around here, the electron hasn't given any energy away. It's got 6 units of energy. It's like if you go to the shop and you buy 6 apples, the shop is your battery, you bought 6 apples and you're carrying your 6 apples around. You then get somewhere that you need to give those apples to. So maybe you're buying 6 apples for your grandmother and you get to your grandmother's house and you give her those 6 apples. Here, the electron has its 6 units of energy, it gets to the light bulb and it gives the light bulb its 6 units of energy. When it comes out then, it doesn't have any energy anymore, it's given its energy away. So it can still travel through the wires because it doesn't need a lot, it doesn't need any energy really to think about doing that. But here it's given it away, so here it has 0 units of energy. Okay, so here it's got 6 units of energy and here it's got 0 units of energy. And it's like you going to the shop, picking up 6 apples, giving them to your grandmother, and here you've got 0 units, you've got 0 apples. So potential difference, all it is the difference in potential, which is why conveniently it's called potential difference. It is the difference, it's going to take me a while to write this, sorry, difference in how much energy an electron has between 2 points. And this final bit is really important, okay? This between 2 points is really important because you can't have a potential difference of one place. You can't ask me what's the potential difference of this part of the wire. You have to ask me what's the potential difference between this part and this part, or this part and this part. You have to have 2 points to think about potential difference. Now potential difference is measured in volts, which is another reason why everyone says voltage. It's measured in volts with the symbol V. And the symbol for potential difference is also V. So it's not like current where we had I and A, 2 different things. It's got the same symbol as it does units, which is nice, but then it confuses other things as well. So it's got the symbol V and it's measured in volts V. And it's measured by something called a voltmeter. Okay, by a voltmeter. And I'm going to not have enough room to write this. And we talked about voltmeters before. Okay, this is the symbol. So in this circuit here, the voltmeter would be added around the battery. We talked about the bulb. We talked about the voltmeters having to be added in parallel. And that is because it needs to count 2 different things. It can't say what's the potential difference of this point here, so you can't put it in series. It has to look at how many units of energy each electron has at this point and how many units of energy the electrons have at this point. So this voltmeter here is going to read 6 volts because the difference is 6 units of energy. So it had 6 lots of energy here, none here. The difference, 6 minus 0, is 6. So this would read 6 volts. Now, we need a potential difference if we want a current to flow. So if I had a circuit that was just a bulb, we talked about this last time as well, with a wire, that wouldn't work because there's nothing to push the electrons around. There's no energy in this circuit and it's not useful in any way. We need to have a battery there, okay, or a power source, but we're going to think about batteries and cells. Now a battery or a cell has its own potential difference because one side, I always get this the wrong way around so I apologise if I do, it's this one is positive and one side is negative. So as the electron goes in to this battery, as the electron travels in, coming along, here it doesn't have energy, it has no energy. But it's given a certain amount, and that depends on the voltage. So say this is now a 9-volt battery. As the electron travels through, it's given 9 units of energy, which it can then give out to the rest of the circuit. And this battery provides the push. It's what we talked about before. Now a battery gives every electron the same amount of energy. It's not going to give some 1 and some 8. It gives them all the same amount of energy. Increasing the potential difference, so if we make the potential difference bigger, increasing the potential difference means that each electron gets more energy for each electron. Increasing potential difference means each electron gets more energy. And we can do that in a couple of ways. We can either just use a bigger battery, so maybe a 12-volt battery, or we can add a few batteries in series. We can have 2, because then the electron would go through each battery and gain some energy in each one. And we're going to talk more about that in the series circuit video. But there's one final thing to kind of think about. So we've talked about the potential difference across a battery, and thinking about a potential difference across a bulb. And going back to our original example with a 6-volt battery and a light bulb, and we said the potential difference across this is 6 volts. Now what happens to the energy that goes through this light bulb? Now 6 units of energy have been lost through the light bulb, and these 6 units of energy, so 6 units of energy, used to be electrical energy. So they started off as electrical energy. Now in a light bulb they're then transferred to light energy and a bit of heat, but mainly light energy. So the potential difference across a component is how much energy is being used by that component and how much is being transferred into another type of energy. So a motor would transfer it to movement energy. A buzzer would transfer this electrical energy to sound energy. So this means that potential difference across the bulb is equal to 6 volts, because 6 units of energy from each electron has been used up and has been changed to light energy. So the way I think about it is that when electrons go through a battery, they get given energy, and that the potential difference is how much they didn't have and how much they do have. And when they come out of the, when they go through a component, it's how much energy they lose. So batteries gain energy, components make them lose energy. If you understand that, you're sorted with potential difference. That's all it is. It is not as complicated as it seems.